In the age of climate change, the railway is experiencing an enormous upswing. More cost-efficient, safer, and more sustainable than all other transport systems, it's the mobility solution of the future. At Plasser and Theurer, we feel like we're part of this system. Ever since our company was born, it has been our vision to make the railway even more appealing. In that sense, innovations have always played an important role. Over the years, many of them have become standards, and they've shaped today's image of track maintenance in a major way. In order to understand the full extent of this success, we have to take a look back at the events of the past. Here we are back in 1953. Building and maintaining tracks was mostly done by hand. Thousands of men laid and serviced rails. The work was extremely hard, occasionally dangerous, and above all, it was expensive. Visionaries like Plasser and Theurer saw there was a great deal of potential in mechanizing these work sequences. What was needed first and foremost were tamping machines that could provide high-quality, long-lasting tamping results. Let's listen to inventor Theurer talk about that.
I met Mr. Plasser, who knew of older machines with a purely mechanical squeezing system.
They were tamping machines with a squeezing mechanism that used vibrating tines. The downside was that these mechanical machines were operated by hand, and squeezing, where the ballast is compacted, was uneven. And I had the idea of using hydraulics. The pressure in the fluid is propagated evenly, and then it's transmitted to the ballast bed and the vibrating tines. The most important thing is that the pressure provides compaction. The pressure was even with the tools, which wasn't the case with mechanical machines. Back then, we already referred to this principle as non-synchronous squeezing, meaning that each tine squeezes until it has reached its pressure. That meant, for example, the amount of compaction was the same under both the left and the right rail. This would have been very difficult otherwise, and railway travel would have been unsafe. Mass production of these machines began in Linz in 1955. Back then, the manufacturing facility only had 9 employees. In any event, we began exporting the machines that same year. The first tamping machine in cantilever design, the VKR-01, was shipped to West Germany. Over time, tamping machine technology became more sophisticated. The first tamping machine to level track itself was introduced in 1960. This machine could tamp 500 meters of track per hour. Then there was the Geomatic in 1965. It was the first machine that could tamp 2 sleepers at the same time. This meant it could treat between 800 and 900 meters of track an hour. In 1970, the first tamping machine in standard railway vehicle design appeared, with a tamping unit between the axles. And finally, in 1983, there was the world's first continuous action tamping machine. By separating the tamping unit frame from the machine frame, the machine no longer had to stop every time it tamped. Instead, it could keep moving on the track. This created the prerequisite for significantly higher working speeds. With this continuous working action, modern 4-sleeper tamping machines can treat more than 2,600 meters of track per hour. Alongside developing tamping machines at Plasser and Theurer, we also focused on mechanizing other work sequences early on. In 1960, there was the fully hydraulic ballast cleaning machine. Shortly after, the assembly line method was introduced. And then in 1968, the first high-speed track relaying train came on the market. It replaced old sleepers with new ones, using the assembly line method. In 1984, this method was also used for formation rehabilitation. 10 years later, these machines were also already equipped with an integrated ballast recycling system. If there's one machine that shows how far this concept has progressed, it's the RUS 1000S, a high-capacity machine delivered in 2020. It only needs one track possession to replace sleepers, rail fastenings, and rails and clean the ballast bed at the same time. The Plasser and Theurer product range includes machines for every relevant work sequence, from tamping to ballast cleaning, formation rehabilitation, ballast distribution and profiling, stabilization and compaction, material logistics, mobile rail treatment, overhead contact line maintenance and construction, to track inspection vehicles. We offer everything from compact machines to complex high-performance machines. And our technological development is non-stop. In 2022 alone, our company applied for 21 new patents out of a total of 936 active ones. In recent years, two aspects in particular have led to decisive leaps in development: the greening and digitalization of the railway. In 2015, our company put the first hybrid track maintenance machine into operation. Equipped with E3 drive technologies, these machines use the electrical energy from the contact wire or battery power, reducing local emissions of both pollutants and noise to a minimum on the worksite. This pioneering role in terms of greening also made the largest order in the history of our company possible. ÖBB ordered 56 vehicles for their green maintenance fleet. That's why it's very important for us, as our greatest asset is our employees. Having said that, we're also strongly committed to sustainable technologies, which is why we started using alternative drive systems for our machines more than 10 years ago. Today we're seeing that the trend, the market, is heading in exactly this direction, which of course makes us very happy. The strategy of sustainability has worked for us here too. The impact of digitalization is at least as strong as that of greening. This applies to the use of digital components and machines, as well as digital methods in railway construction. Today, the Unimat 09 4x4 4S E3 turnout tamping machine performs all steps in turnout tamping automatically. With the EM100 VT track inspection vehicle, it's possible to completely measure a 50-kilometer railway line within 2 days and provide all the data for generating a digital twin. Plasser and Theurer supplied more than 17,400 machines to over 110 countries by 2022. Around half of these machines are still in use. This is one of the reasons why customer services are experiencing an enormous upswing. 22 partner companies provide professional and reliable service in every region around the globe. With this global network in the background, today at Plasser and Theurer, we're developing more and more into a service partner that offers services throughout the entire life cycle of the machines. With servicing, retrofits or upgrades, they're looked after over the entire life cycle. 70 years of Plasser and Theurer. The past has been a constant success story. But where's the future taking us? Let's have Johannes Max Theurer, Plasser and Theurer's current CEO, answer that question. Our company started off in 1953 by using hydraulics. And back then, hydraulics was a very, very modern technology that came from aircraft manufacturing. In the past 70 years, most modern technologies that have emerged kept being used again and again to make them accessible to railway construction. We're completely convinced that the railway system has so many advantages that our actual core segment, the railway infrastructure for which we supply our machines and services, also has a great future.